Good morning, good afternoon, everybody. Today we are talking about two variables. So we are starting our new unit, which is exploring two variable data, and one of the big questions we want to ask is, are two variables associated with each other? That's our EQ for today. How can you tell if two categorical variables are associated? So we're going back to look at categorical variables, and we're going to look at these things called two-way tables. Now, you can actually find this in the AP Statistics textbook website under Chapter 1.1. It's marginal and conditional distributions, but this actually goes into Unit 2 based off the AP Classroom Course Exam description. And why is that important? Because you might be interested in looking at some supplemental videos to go along with this one. In that case, you can find those as topics 2.1, 2, and 3. On AP Classroom, you can find some other short video lectures. So let's get to it and start talking about some stuff today. So what you guys are used to looking at when we're talking about categorical variables is you have some kind of total table over here where you have your total and then you have a variable's values all listed out in several different columns or different entries. But now what we're going to do is we're going to extend this into a vertical dimension as well, and we will have a second variable represented in multiple different rows, and then we're going to have a total down here at the bottom. Okay, so we have a total row and a total column, and then ultimately those will give us an ultimate total value all the way down here. So this is what is known as a two-way table or a contingency table. And what these two things do, or the two-way table does, is it compares two or more distributions of categorical variables. Okay? One of the things that we want to look at is the marginal distribution. Now the marginal distribution is just looking at one variable at a time. It's the frequency of a categorical variable against the table's total. So what we would be doing is we are looking at all of these totals that are here, comparing that to the table total. Or we might be looking at all of these totals here, comparing that to the table total. So that should hopefully help you understand why we call it the marginal distributions, because the distributions are found by looking at the margins. Now, if we want to compare two variables against each other, what we need to do is examine conditional distributions. Conditional distributions are the things that are made up inside of here. The conditional distributions are going to be looking at each individual cell. Specifically, a conditional distribution is the proportions of one category against different values of another category. So what we are doing is we are looking inside those cells, right? We are looking at the cell value and we are dividing it by the column total or the row total. Okay, so we are looking at a variable inside here, or variable's value inside of there, and then we're going to divide it by either the column total or the row total. And that's what we mean when we start looking at a conditional distribution. Okay? Now, why is this important? Why do we want to look at conditional distributions? Because they tell us if two variables are going to be associated with each other. Now, two variables are associated if knowing the value of one variable helps us predict the value of the other. Okay, it's sort of like cause and effect, but not quite. It's not quite as powerful as cause and effect. But what it does is it helps me start to see if I know the understand between how one variable is related to another, I can start to make accurate and reliable predictions, and that's what statistics is all about. So how do we tell? Well, you compare conditional distributions and you see if they are associated by basically asking this: is one value different proportionally than another? And if they are, then they are going to be associated. Still might be a little bit unclear. Let's take a look at an example. So in this example that we want to look at, we're looking at data from the Pew Research Center. We ask a random sample of 2024 adult cell phone owners from the United States which type of cell phone they own: iPhone, Android, or other, which includes non-smartphones. Here are the results broken down by age category. So what we should be able to see, this is a two-way table. We have multiple rows and multiple columns, and this should tell us that we have two different variables. One variable is these columns, and this is going to be our age group, right? That's the actual variable itself, is what age are we looking at. So this is going to be considered variable 1, and then our other variable is going to be representing in these rows here. So this is our variable 2, and this is phone type. This is just kind of helping us understand the language of what we are looking at here and recognizing that we have two different variables. Now, let's go ahead and take a look at our question. What proportion of adult cell phone owners in this sample own an Android? Okay, well, before I do that, I want to kind of get some more basics of how to read this table and how to understand the what the prompt is telling me. So I see down here, this is what's known as my table total. And this is actually going to usually represent my sample, or maybe my population, depending on what we are looking at, but it's just how many total individuals we found. And so this is my sample, 2024, and who were these people? They were U.S. adults, right? Now, that also gives me a big hint about who my population is. If I asked only U.S. adult, we are asking ourselves, hey, where did our sample come from? Who did we want to know about? And it's all U.S. adults. Just to remind ourselves of some of that basic statistics language, identifying the sample and the population. Okay? Now, let's go ahead and clean up here a little bit so we can actually answer this question. A, what proportion of adult cell phone owners in this sample have an Android? So we kind of look at this language here of adult cell phone owners. It's telling me what my condition is. And usually that's going to tell me if it's a conditional distribution or if it's a marginal distribution. Well, who are the adult cell phone owners? That's actually comprised of the 18 to 34, the 35 to 54, and the 55 and up. All three of these different ones. So it's telling us we don't care about that first variable. It's telling us we don't care about what the age group is. What we're going to be looking at is the number in the total here. Okay? So, which value in the total do we care about? We care about those Android owners. And there are 503 of them. So, for part A, we can find the proportion of adult cell phone owners that own an Android is 503 out of all of the adults in the sample, 2024. And doing some very quick reducing here, I can see that's about 25% or 0.25. So what that tells me is that of all adult cell phone owners, about 25% of them own an Android. And you can start to see how this could be really helpful in a business setting. Maybe you're a market research developer for some kind of app and you want to know, okay, who should I be developing this app for? Android owners, iPhone owners, or something else? Should I broaden my horizons a little bit? By knowing these marginal distributions, that can help us make decisions. Let's go ahead and now take a look at question B. What proportion of 18 to 34-year-olds own an Android? So that word of, again, is what's huge in telling me that I am looking at my condition. So of is telling me what condition should I be considering. Okay, so now I can see that I'm only looking at the 18 to 34-year-old age group. Okay, well, so that is 517 people, and that's my denominator. You'll notice my denominator now is not the table total, but it's one of those column totals. And this is going to be true for any conditional distribution. We're going to be having a denominator that's either the column total or the row total. Now we just have to figure out what cell, what inside value. Android owners. And that's 214. Now, 214 divided by 517, that I need to go to my calculator for, but that is about 41% or 0.41. So now I can see that if I'm looking at 18 to 34-year-olds, I have about 41% of all 18 to 34-year-olds that are Android owners. So a couple of other things I want to write down here. First of all, we should recognize that this is indeed our conditional distribution. Okay, we know it's a conditional distribution because we were looking at one of the column totals or row totals as the denominator. The marginal distribution, however, we know it's a marginal distribution because both of the values of our fraction came from the margins, and our denominator was the table total. Now, how can we tell if these things are associated with each other? I can tell that these things are associated with each other by kind of comparing these two things. If age group didn't matter, then I would see that these two proportions would be approximately equal to each other. But what I can see here is that if I know somebody's age, if I know somebody is 18 to 34-year-old, since this is a higher proportion than this number here, 41% is more than 25%. If I know somebody is 18 to 34 years old, that tells me I should know that they are more likely to own an Android. And here I could even add just an additional note, it appears age and type of phone are associated with each other. So now let's take a look at some more examples and dive a little bit more deeply into this, because this is only just the very basics. Okay, let's really try and prove this idea of association and also revisit some of our ideas from the first unit. Question C says to use the cell phone data to calculate the marginal distribution in percents of each type of cell phone. Okay, so we are concerned about the different types of phone. So there's iPhone, there was Android, and then there was other types. And we want to find the marginal distribution of each one of those. Now, since it's the marginal distribution, I know that my denominator is going to be that table total, the entire sample. So each one of these is out of 2024. Now, let's go and find out how many each of these were. I had 467 iPhone owners, 503 Android owners, and 1,054 other owners. So we had 467 out of 2024 that owned an iPhone, 503 out of 2024 owned an Android, and 1,054 owned an other, right? Now, we knew this was about 25%. Then we can say that 467 out of 2024, it's going to be a little bit less, I can tell that, but I need to go to my calculator for that, and that looks like it's about 23%. Then 1,054 divided by 2024, going to my calculator for that, that is approximately 52%. Okay, so here I can tell that the majority of owners own some other kind of phone. Now this is probably a while ago this data came from. This might have been about 10 years ago or so, but it still gives us at least an idea of how to work with this kind of information. Now, D says to make a graph to display the marginal distribution. This is just like what we have done in Unit 1 with categorical variables. So I'm going to go through this very, very quickly. Alright, so here's our graph, and we can pretty clearly see adults were more likely or most likely to own an other phone based on this sample. iPhone and Android were almost equally likely to be owned. You could even add in there, if you want, that somebody was twice as likely to own an other phone compared to iPhone or Android. Okay, but this is a very basic understanding. We know that there could be some what we call lurking variables. There could be other factors that are going to determine the type of phone that somebody owns. One of those things that we happened to collect data about was their age group. Is somebody that's younger just as likely to own an other phone as they are if they are somebody that is considerably older? By examining the relationship between two variables simultaneously, we can start to understand the nuance of our situation and start to make more appropriate decisions just by having some more information. So let's do that now. Of the three different age groups, what percent of people use iPhone, Android, and other phones? Then the question is there an association between these age groups and the type of phone they use? Let's justify our answer. So the first thing I see in this example is this big keyword of. Again, what that does is it tells me what my condition is. The condition is important because the condition is going to be the denominator for any of these conditional distributions. Okay, so that means we want to set this up to where we are looking at how many age group or how many people are in each one of the three different age groups. Now we want to know the percentage of people using iPhone, Android, and other based on the age group. Okay, so let's go ahead and set up our table here a little bit where we're going to say I've got iPhone owners that I'm going to look at, I've got Android, and I've got other. Then I'm going to break things out by the age group, 18 to 34, 35 to 54, 55 and up. And the first thing that I want to do, I'm going to divide this out a little bit, is I want to see what's my denominator for each one of these different sections, okay? So I need to find out how many 18 to 34-year-olds there are, and that's going to be in my first column. There are 517 18 to 34-year-olds. So that's going to be the denominator for every one of these fractions that we are going to work with. So that's out of 517, that's out of 517, and that's out of 517. Now we're going to do the same thing for the 35 to 54-year-old age groups. There are 637 in the 35 to 54 and 870 in the 55 and up. So out of 637 for each of these, and then 870 55 and up. Now what we'll do is we're just going to look inside each cell to figure out which is going to go into the numerator, and we'll go through this kind of quickly. Alright, so here is our conditional distribution numerically. What we've done is we've calculated the percent of each different age group, what type of phone they use. And we see that 33% of 18 to 34-year-olds are going to use an iPhone, whereas only 15% of anybody 55 and up are going to use an iPhone. Okay, and that gets even more pronounced, that difference, when we start to look at Android. In the younger age group, 18 to 34, 41% own an Android, but in the older group, only 11%. And then we can see that, again, the drastic change, the complete opposite thing going on with the other type of phone. 18 to 34-year-olds are by far the least likely to be owning an other type of phone, but the vast majority are going to, of 55 and up, are going to be owning an other phone. Couple of other things that we can see with this: the totals for every one of these are going to all add up to 100% in each of these columns. You can prove it to yourself by adding these. Now, what we would want to do is recognize, because of those differences across here, we can see that it seems like based on their age group is going to be associated with the type of phone they're going to use. Okay, now we can visualize that by looking at a graph. Let's go ahead and do that. Okay, so what we're going to do is we're going to draw our X and Y axis, and I'm going to plot things similarly to what we did before, and I'm going to do this kind of quickly. What's going to be different about this bar chart, though, is we're going to make like a side-by-side bar chart. This is what can show association and show multiple variables at the same time. Similar to what we looked at before with segmented bar charts, now we're going to look at a side-by-side bar chart where you'll see that I have a legend that is going to accommodate the type of phone, and then the x-axis is going to be our condition, the age group. So let's take a look. So this visual representation is really going to drive home the idea of how they're associated with each other. What you want to look and see is if there are differences across the age groups. Since the x-axis is our condition, that's what we want to pay attention to. And what we can start to see is the difference in the heights of those bars across the different groups. And we can really see here that if somebody is in that 55 and up age group, they are drastically more likely to be an other owner compared to if they are in one of these other age groups. And that's how we can really see the ages associated. Now, you could have done the same thing by looking at those Android images too, right? And we see that as someone gets older, they are more like or less likely to own an Android They're less likely to own an iPhone because these bars get shorter, but they are more likely to own the other. So again, what we're doing there is we are looking for those differences across the age groups to see the association. Okay, so that does it for this lecture. Thanks for watching, and I will see you guys next time.